Thank you. Well, super happy to be here. Thanks for having me. So I'm Bastien. I'm the co-founder and CEO of Rayon. So Rayon, we're a young startup, 2 years old, only 10 people, and we're building a CAD web-based tool. So a CAD is a tool used to draw stuff, most often buildings, the built environment. So a bunch of lines, vector graphics, basically. And so we're doing this in the browser, and we decided to build it with Rust in big part. And so tonight I'm not going to be speaking about everything we do in Rust, but a subtopic which is ECS, Entity Component System Architecture, that we use and why do we use it. And we could try to actually build one, a very simple one. So just a word about our architecture as a web app. So we built our core engine in Rust, and then we compiled to WebM with binding with Rust engine, and then we did the UI in a classical TypeScript React interface. So very simple, all the data, all the memory reside in the Rust linear memory, and then we get the UI and the network layer in the React app, and we sync with the backend. And kind of the nice thing is that we also use the same engine in the backend because we have a Rust backend, so it's pretty cool to be able to use the same code in the front and in the back. So pretty much the same architecture as Figma. You might know Figma. It's pretty much the same thing, but we use Rust and not C++. So a question we often get is why Rust? Why do you go through the pain of building a web app in Rust? Why not TypeScript? A few reasons for that. First one is better performance. So some people might say this is not really true. I guess you could have the same performance in TypeScript JS, but it would be super hard. If you look at the Figma experience, they were doing ASM.js and then they switched to WebAssembly, and they said that they had like almost a 2 to 3 times speed up, even though they had already a very optimized ASM.js app. But the thing I found is it's not necessarily better performance, but it's much easier performance, because if you want to do what we do in the web, then you have a lot of memory issues. Models can be huge, hundreds of megabytes. You can have hundreds of thousands of entities, and it's very important to be able to have full control over the memory layout. And it's hard to do if you have to go through V8 and the GC and all that stuff. You can do it, but you must be much better than I in V8. So much easier. The other one is that it's cross-platform, so we have the goal at some point to also do a native app, and it will be super cool to just reuse the code base we did in Rust. Fourth point, it's a personal point, but I feel it's much easier to maintain a large, complex code base in Rust than TypeScript. Some people might find the opposite, but doing both, so much easier in Rust. And finally, great talents. Like people that love Rust are often very good engineers, so that's a bonus. Many other stuff we could say about that, but this is not the topic of tonight. Tonight, we want to talk about ECS. So first of all, there are some great people that talked about that are much better than me, so you should check it out. Especially the talk from Catherine West is quite famous. It's a very good talk about why you should use ECS or the reason to use ECS. But there are other resources out there that are very good. Adam Martin stuff is also very good. So I think to explain what is an ECS, and first of all, this is not a talk about why you should use an ECS. It's just a framework. You can use many other frameworks. It's more about understanding what is ECS, how come this architecture can make sense. So very simple. I'm not trying to evangelize about ECS. Many different architecture work as well. So what we could do is just look at a minimal CAD tool and try to build it and feel how ECS can help us in that endeavor. So a CAD tool, very simple, basically polylines on the screen and layers, just that. And so the idea is that we want to draw stuff, so we're going to have some kind of world that will have our data, and the user is going to have some inputs. We want to mutate this and render the stuff on screen So that's, I think, kind of the classical interface for a design tool. So if we look at the way we could do that, so we would have a struct, so with just polyline, it has a vec of points. A point is a very simple structure that has two coordinates, f64. It could have a color, why not? And it could have a layer, and then we have a struct that is a layer with a name and so forth. And then we need to store all of this in somewhere, so we call that the world. For example, we could have two fields with just vec of stuff. And then our world is going to have this interface, which is very classical, like it's going to be able to be updated through inputs. It's going to be able to initialize through maybe some kind of serialized data, and we want also to be able to render it. So very simplified example. The first thing is that when you're building a CAD system, often you're going to think oriented object programming, because object programming, CAD is about objects, like a polyline is an object, a layer is an object, so it would make sense to use that paradigm to do it. The problem that you will run into is very classical. It has to do with cross-cutting concerns. You have many stuff that is in between those objects, and quite fast you're going to think, okay, how am I going to express and drive the code by removing stuff that is shared across different entities, and it can get quite bad. Having said that, almost all CADs that we use are built through that paradigm. So AutoCAD, Rhino, they're all built in this way in C++. But in Rust, we don't have inheritance, so this is not really the way to do it, and we can do better, I think. So right from the start here, you can see that we have some stuff that is shared between polyline and layers. Mainly a layer can be itself inserted into a layer, so we have that kind of relationship that is the same. And also, we see that we have something here that is quite nasty. So a polyline is supposed to have a layer. Right there, I just put it in a box. This is not going to work, right? Because you want to be able to mutate that. You don't want to own the object. You might want to own a reference to it, but you don't want to own it. So that's the first big decision you have to make. You could do this with smart pointers, but it would really suck, I think. And the way most people do it is via indexes. But that's a big decision right there. I know some people will say, this is typical Rust. You have to find the borrow checker, so what you do is try to build your own memory layout with indexes, and then you have to do your own GC, because those index can be invalidated and so forth, and you just turn around the borrow checker, which is kind of true. But also I think it's a nice abstraction to have, and I don't think it has, even though those indices and pointers are going to be quote-unquote unsafe, because if you delete an entity, then the index might be not valid anymore, you could have use after free. It's not the same as your pointer that will have undefined behavior. So my opinion is that it's fine, and it's much better to do that rather to have RevCell and RC and art and smart pointers everywhere. Well, you would run into a lot of trouble. And almost everyone does this. So I think it's a nice decision. But it's an important one. So the first thing we do, we give IDs to stuff, which is a usize. So then the question becomes, okay, I have indices, but I'm storing this into fields. It doesn't really make sense. Maybe if I have indices, I should index with those indices in like a global data store. So that's the question: how do we do that? How do we store like a bunch of stuff that have different shapes? So polymorphism, basically. So trait objects. So this is one way to do it. You will build like a trait called entity that has all the method you need, and then you just store it as a trait object with a pointer boxed into entities. That could work, but right there you see there are problems. First one, you have to deal with trait objects, and they have limitation, as you know. But also you need to have a very huge interface for the trait entity, and some method might not make any sense. For example, polyline is going to have a name, so what should we do? It's not going to do anything when we set the method. So it feels kind of bad, but it could definitely be done. Another one would be to have a big enum. Enum are great. So you would just have an entity that can be either a layer or a polyline. That's very nice, and then you can get to match and do stuff with the layer or the polyline in your update loop, for example. But so pretty good, you could do that. The problem is that your enum might get very big, and you might consume too much data, so you might have to box stuff to reduce the layout of memory of your enum. But also here, you kind of have to know for each enum what kind of stuff you can do, so it gets quite unwieldy very fast. We get like a huge enum at the end, and for every method using the entities, you would need to match on the enum. So that would create a ton of boilerplate. But for a small project, could definitely work, I think. Another option would be to say, okay, let's just make a big struct and have all the field optional, and then we can just check if they have a field and do something if needed. We don't need too much on the enum. We can just be interested for a specific field that we need, which is a bit simpler. You will have less control flow that way, but still it doesn't feel really good, right? To have a big struct with optional fields, and you're gonna get to do a lot of unwrapping, of course, if you do that. But more to the point, if you start to do real stuff, let's get an example. We're going to be able to count the number of stuff that is on a layer, the number of polyline, all layers. And we want to cache this because we think it's faster to do it that way. So we just add another property to the entity. Let's add a count here. And then we're going to loop in the update on the entities. And if they have a count, we're going to use this method to update the count. So basically, just iter on all the entities and count how many of those have a layer equal to the given layer. So obviously this is not going to work because we're sharing everything and we already have immutable references to the entities, so we cannot do that. The compiler will complain, which is normal because we only have this big object with all our data in it, and if we need to mutate it while referencing the data itself, it's not going to work. So we're stuck with the borrow checker. So first thing we could do is say, okay, we just need to get the count out and just maybe do a hash map with the ID and add the count for each entity in the hash map. That way we can use the data in the entities and mutate the count in the same goal, in the same path. The compiler will not complain, this will work. So that feels like a good direction. But then if we do that, why not do it for every single piece of data? And that's basically the start of the entity component system. So what we will do is say, well, just make a vec of IDs, those are my entities, and then I'm gonna just take out all the fields of my big structure and have hash maps with IDs and the corresponding value, so let's call it components, and have one for each. So we are just splitting the data from a struct of arrays to, from an array of struct to a struct of arrays, basically. And this is really what the entities component are all about. So that's the idea. Instead of having structs, you just have some big kind of tables. And it's very similar to what an SQL database would look like. And then you have entities, we are basically like a foreign key on each table. And what you want to do is have some query where you can inner join on different tables and get those values back, and then you can work on them. But the interesting part is that it's basically composition pushed to the extreme. So it has some nice upside. The first one is that you can decide that anything can be anything. So for example, previously we had a name for the layers. So we would have a name component, and we can decide, oh, maybe my polylines, I want to give them a name. And I can just use that component. If I give it to an entity that has a geometry, it's possible, I can do that. I could also decide that maybe layers could have a clipping mask, which would be a geometry. I just need to add to an entity that has a layer comp, a geometry comp, and that could work. So it's very nice that to be able to compose all of this. The downside, of course, is that you don't really need to think about object as you would before, like something that has specific fields. It's more like it could have anything, so you don't have any guarantees that they have the specific sets of fields you need. But that's okay because you only operate on those sets of fields, in fact. So that's the basis of it. One other very important advantage of doing this is that if you do that, then you have a nice layout in memory, and you can have cache locality because you're going to store the same kind of things in a VEC close by, and often you're going to do iteration on those components. So for example, you're going to, I don't know, tessellate all the geometry, so you're going to iterate over the VEC, and all the next components are going to be close by in memory, so you can have nice cache locality and better performance in that way. But I don't think that's the main reason to do that. So now we have done this, but it doesn't feel very good. We want to do it a bit more generic. So we're gonna have like a generic storage with a hash map on the type T, and then we're gonna have some method, basically create a new one and iter on it. And then we're gonna use an AnyMap to store it. So AnyMap, it's a wrapper basically on a hash map with type ID, and then give back a dynamic type trait any. So the idea is that you can store one thing of one type in it, and you can get back this one thing of one type. You cannot store two things of the same type in it. That's not going to work. They're going to be erased because the index of the hash map is a type ID. So it's very nice because that's exactly what we want. We want to be able to store storage inside the AnyMap, and we can get back the storage we want on the specific type. It does mean though that you can only have one type of component per entity. That's basically a constraint you always kind of have in ECS. And so the way we work is this: we would just insert in the AnyMap the storage with a new value, and you can get it back either with a mutable reference or a non-mutable reference. And then you would just register the components through this method that we've seen before. And the update becomes this. So you just get the storage from the world and you can operate on them. Very simple. But if you do that, the compiler is going to complain because we're getting a reference mutable from the storage and the AnyMap, and also a borrow. So it's going to say you can do that. So we just need to add a couple of ref cell and use the interior mutability pattern, and then it will work. So just a bit more borrow mut, which does mean that if you try to borrow the same storage twice at runtime, you will get a panic. And actually this is very similar to the spec ECS architecture, and that's what happens. And then we put it all together, so we allocate an entity. So we did a very simple thing, which is we only create new ones. We never invalidate the index, so we just add one. Of course, that's very simplistic, but it works. And then we add the components inside the storage for each entities. For example, for a layer, we're going to add a name and a count. And for a polyline, we're going to add a geometry, and we're going to add a layer. And then we can just do what we want. And the count. So before you saw that for the count we had some kind of method that would just iterate on the entities, and that feel like an abstraction that would be nice to take out and to put into a specific type, and that's kind of the idea behind system. So we could create a trait, let's call it system. It runs with a single argument, which is a borrow of the world, and then we can implement it. So let's implement it for update count, so we don't need any field. It will be an empty struct. We implement the trait, and we get basically exactly the same thing as we did before. And then we can store the system as, I don't know if you see it, but it's down here as a trait object. And the nice thing with this is that our main update loop becomes, I don't know if you can see it, but you can just iterate on the systems and just run them. So what we've built essentially is the idea that you have like a more declarative style of things. You just write your system, and then you have a main loop that's just going to run the system one after one and updates your data from one state to another very simply. And this is basically the pattern of the ECS. So we built an ECS. We had entities, components, and now we saw system. And so that's it. We have something very simple. But in fact, it's not very useful because the main point about an ECS is to be able to do joins very fast. And we didn't really implement that. So an example would be here. I want to compute the bounding box of my geometry. They have a transformer geometry. So I want to join on those three components and run the system that will transform the geometry, compute the bounding box, and store it in the bounding box. So I need to be able to get very fast the entities that have those three components. And that's what ECS does, basically, frameworks. And there are different strategies to do that. So Specs, for example, is one of the famous early ECS. They use bitset for this, and then you can mask on the storage to get very easily the component that the entities have. But other ECS, more recent ECS, use different paradigm. One we call the archetype, which is the idea that if you know what kind of components an entity has, you can store them more efficiently. And this is what BVECS does. So the nice thing about this this architecture, I would say, is that it matches very well with a multiplayer real-time tool, like a CAD that we built. Because since you're storing all the components inside VEX, you get this very atomic mutability on specific components that is very controlled. You cannot modify anything without getting the storage correspondingly, so you can add middleware at that point to do stuff like flag modification, for example, to follow the changes. And also, it's very clear where the data lies. So one thing we do, for example, is when we commit a modification on the drawing, you're doing something, you need to sync with the backend. We actually look at each component type, what kind of value you have now for which entity, and that creates a commit that is sent to the backend, and then you get it back to another client. You just apply it, and the systems are running on each loop, and they will react to that new data. And that works really well because if you did something else, for example, if you had this kind of system run after somebody, the user has an action, then you might introduce bugs where something is happening only if the user does it, not if it comes from another client, which is a big problem in multiplayer tools. So this works really well. It's really the idea that the data flows, and then you run the system on the data, you create new data. And it's much simpler to reason about when you're doing a multiplayer tool because you don't know where the data is going to be modified. So this is why we really like it. So a lot of crates that are great for this. So I think one of the main ones today is the one from Bevy. It's really used in video games, of course. Specs was the old one, but it's not maintained anymore. You also have Edict, which is very good, and many others. You can find them on Are We Game Yet? So I don't recommend to build your own ECS. It's more easy to use an existing one, but it's interesting to understand how they work. That's it for me. I hope I wasn't too long. And by the way, we're hiring, so if you're interested in doing stuff like that, send me an email. So do you have any questions?
Which ECS are you using?
So we're using Specs because when we began the work on the software a couple of years ago, it was one of the nicest ones. It's good for what we do. I mean, we're really used to it, but it's not maintained anymore, so we might migrate it or fork it. We'll see. I would not recommend to use Specs now. I would recommend to use BVECS.
Yeah, I was wondering, your slide makes it look a lot like a database where you would have joint information and stuff.
Yes.
So I was wondering, in the most state-of-the-art ECS, for example, BV1, do you know how deep the algorithm work is to make it efficient to query things? Is it like on the level of a database, and if yes, why don't they just use a database as a backend?
Yeah, it's a good question. It's very close, you're absolutely right. It's very close to that. It's not as deep, of course, as a database. It's nothing like PostgreSQL or something like that. So BPECS, I don't know exactly how it works. I know it's based on archetypes, so it's a bit different from specs. But it's simpler in a way. You don't need. There are many things you don't need, like for example, the queries are basically only inner joins. So you don't need the whole SQL language with you. There is also guarantees you don't need. It's also very synchronized. But one thing I didn't mention, of course, is the nice thing also about ECS is concurrency. So since you have systems, you can decide which system can run independently and have them run in different threads. And also you can have inside a system, which is often a big loop over a query, you can decide to parallelize it on multi-thread. So you have those kind of two potential for concurrency that is very nice. So it also plays very well for multi-threading, which is one of the perks as well as for ECS. Yeah, sorry.
So I have a question. If we compare two solutions for the storing, so the one with many options and the one with hash map, there could be one problem which I'm not sure how to solve. So what if we want to render in multiple threads or something? So hash map won't be thread safe. Either a solution to it or something like this.
Yeah, it's true. So of course it's a very simplistic example. So internally, most ECS they use something quite different for the storage, so that they can be thread safe. So yeah, you're right, absolutely. So often they will have a bit of unsafe code there, and they do some kind of magic as well to be able to really know very fast if an entity has another component, to be able to do that for sure. Yeah. But the nice thing is, since you control the point where you get the mutual reference to your storage, you have a better idea of when you are mutating data, so you can use that to your advantage. This is one of the ideas behind the architecture, is really to start with the data. So that's why we talk about data-oriented design. Really, lay out your data and then build the rest from there, and have a very clear view of where the data is stored and how it is accessed and mutable. Yeah.
Yes. Did you run into problems using WASP using WASP with the memory, because you're limited in memory, and also with the network, because I don't know how you handle sending the batched updates to the backend in the end.
Yes. So memory-wise, we didn't really run into any problems. So we have you're limited to 4 gigabytes per tab in WASM. It used to be 2, now it's 4 in most recent browsers. So I mean, it's quite a lot. We try to not use that much. So that's not an issue. We do have some issues though with allocation. So you have a specific allocator in WASM for Rust, which is not that efficient, and so you might, we see that we lose performance on big models when we have a lot of memory. On the linear WASM memory, we feel like the allocator is kind of struggling, and so we see that. But it's not a huge problem. We didn't really run into that problem. The other question about the network. So yeah, they can be quite small, the modification, or they can be quite large. We don't really have a problem. We use kind of push-pull mechanism. So we send the modification through an HTTPS call. So we can have quite large payloads. So it's not an issue. But most are very small, because when because we're only sending the diffs, we're not sending the whole state each time. So mostly they're a few bytes. They can get large if somebody does, for example, select everything, copy paste, which is an action people do, and that's hard to handle because you're gonna have a lot of data. So we handle that as well. In most scenario for multiplayer, what often is done is not to send the data over the wire, but the commands, which are also a lot smaller, and then have the commands replayed on the back end with a similar client, and then send back the new data. So it's also a way to do that, but that's not what we're doing. Sorry. Yes?
I have two more questions, but I'm not sure we have time. But the first one is on the ECS systems, like once again VV1s for example, the concurrency level, is it per storage or is it even more fine-grained than that?
Yeah, it is more fine-grained than that. You can have, for example, in Spec, you can do joins on the storage, but you can also do par joins, which are going to be, parallelized on the thread you
Okay,
provide.
so you have to use some primitive of the ECS system to have parallelism
Yes,
deeper than the storage level, but
yeah,
you can have
exactly.
it. Okay.
Yeah, it's built. One of the ideas that it's built into the framework, so you don't have to manage that yourself.
Okay.
And for the systems, often what you're going to do, so I didn't talk about that, but you can have some kind of dependencies per system, because one might need to run after the other. So you just put those kind of relationships, and then you can let the framework decide how they're going to parallelize. The idea is that what is needed to be sequential is sequential, and what can run together and together.
And another question maybe is for the WASM to canvas thing. What would you, if you had to give advice to someone who was interested in using WASM to write on Canvas, what is the rule of thumb to know where it's going to be more efficient to have code in WASM because you're paying the cost of passing from WASM to JS,
Yeah.
or to just stay in the JS world?
Yeah, it's a good question. So we use WebGL, so I don't think that's a lot of, we mainly do dual calls per frame, and we try to limit the dual calls anyways. So it's not the cost of the FFI is not that heavy, to be honest. When I began, I was very aware of that, and we tried to limit the calls, but in fact, it's not the bottleneck. So I would not worry too much about that, unless you're doing like 1 million FFI call per frame, which is going to be slow. But if it's only 1,000 calls, it works nicely. I think it has more to do with what kind of work you do on the CPU and how much you need to optimize that. I do think there are very few cases where you need WASM because PA is very fast. So if you have a lot of data, that's one. And if you need to control the way it's done, that's another one. Also, I do feel like with shared area buffer and atomics in WebAssembly, you can get a nicer multi-threading experience in WASM than in JS. So it's also a plus in that regard. But it's still quite early. So yes.
Are you using so you are using multi-threading in WASM, or are you not?
No, we're not.
Yeah.
We're not, because we don't want to deal with the cross-origin, restriction that you have.
Yeah.
But we're waiting for the RFC to evolve so we can have at least pop-ups. And then if we do that, yeah, we'll definitely do it.
Oh yeah.
But the problem today is to do atomic and multi-threading with shared area buffer. You need to have a cross-origin isolation due to Spectre, and this is quite a pain because then you can be embedded in iframe. You can use any iframe, so it's a big constraint on your website. And if you have it on the domain, you have it for the whole domain. So that's one of the reasons we don't do it. But otherwise, it works nicely. We want to experiment on it. It's quite interesting, and we definitely are going to do it. Yes.
Is the ECS goal to replace a database, or is it just to work with, if you're using SQLite, for example?
Yeah, no, I think I don't think it's supposed to replace database. It's quite a different use case. But on the client, if you're using SQLite on the client, yeah, definitely. You could definitely replace it by something that is kind of more efficient. But it's also nice because the components tables map very well to a Postgres database. So one of the things I didn't talk about is one of the plus of ECS, and Adam Martin talks about that, is how easy it is to make the code evolve. Because if you add features, often you're going to add components, which is very easy to do, and also it maps well to a backend if you need to store things in tables. it will look a lot like your front end, so the data layout is going to be the same. Each component is going to get its own table, basically, and you're going to have the entity as one key. So we don't do that because we have too much data. A single model can be millions of components, so we don't do that way. We store them as a blob. But in the example Adam Machine gave on MMO, that's what they were doing. All right. Well, thanks for listening, and I hope it was interesting.
Hi everyone. Thank you for coming to this Rust Meetup. Nice to meet you. My name is Oscar. I'm CTO at Stockley. And secondly, sorry for my voice. I kind of lost it recently. Today I'm going to speak about data validation. So what's the issue? User inputs are not to be trusted. Basically, when you build APIs, CLIs, you get inputs from different users. And these inputs may not be valid. For example, when calling an API, I might do a typo writing my ID, which would provide an incorrect ID, and therefore my function would not be able to return the expected output. The data validation has a few challenges associated to it. First, validation needs to be simple to write. If it's very complex to validate any input from the user, developers tend to forget doing it. And then you get unexpected error and you don't know why your API doesn't work. And it must be explicit at reading so that follower developers may easily understand what assumptions they can make on the data they are receiving for when writing their application. And secondly, you must provide good errors. As a fellow developer, please avoid just returning bad requests with no details, no help, nothing whatsoever. It's probably one of the most frustrating things you have when dealing with external APIs. What we like in errors, good errors for us, have 4 different things. First, the invalid value, to see which one. Mostly, sometimes you say this value is invalid, and you say, but not, I've written the correct value. There's a typo in it, you don't see it. Displaying it to the user will fasten the debugging process. Secondly, why is the input invalid? Hopefully, all your documentation have all the specs that you've added in your API. Often, that's not the case. If you've forgotten a specification in your documentation, adding it in the error is a good way not for a developer to be able to learn it. Secondly, a location. Where was the field, the invalid field provided? I'm sorry, is it, can everyone read here or? Allocation, where is the value? Especially for APIs that can have multiple fields, similar fields. To decide which one. You provide a list of values, the third one is invalid. It's good to know that it's the third one that's invalid and not check all your different fields. And finally, a help. That's the least important ones within the four, which would be how to fix your error. Most of the time, it can be self-explicit, but sometimes it's not self-explicit. For example, if you have a set of accepted values, it's really nice to input to display the list of accepted values. Invalid value, bad variant, the list of accepted values is, and you can put the list of accepted values. Okay. Perfect. Typically, it would look like something like this. You get a location, where will I find my my field, and why it's not. Here the value is definitely not provided because apparently we provided an empty string. Okay, so how do we tackle these challenges at Stockly? First on basic concepts, so that we are. What's amazing is this thing is coded by Google, and yet it crashes. Okay, we're back. Okay, we'll speak about input is the actual data provided. It's not the request, it's the data. So a string, hello world, a number, 12, a float, 6.5. A property. Property is a specification the input must follow to be valid. For example, if it's a price, it should be strictly positive. If it's a string, sometimes it should be non-empty. A lot of different possibilities. What we call validation, the process that checks that the field is has a property. Validate will say that property, an input is validated once it has all the properties have been checked. And you say it is invalid if at least one property is not checked. So invalidities. Okay. Invalidities. Invalidities, this will be the basic traits we'll start working with. Invalidity will try to attach three different data on it. We'll try to display what makes the value invalid. The explanation, it should be non-empty. We'll try to attach what we received, the got value, the input, and optionally, a help on how to fix it. And typically, as I'm going to have to display to the user, I'm going to ask that it implements display, and debug, because when you're debugging, you want to know more precisely what happened, very useful. And send sync, because most of our use cases are doing APIs, and responding to APIs, you can need your errors to be sending. Which provide such example. Let's say we want to validate strings. If you want to validate string length, we'll therefore derive the invalidity on the string length invalidity structure, which will keep a reference to what we received in order to display it to the user, and a reason on why was this string not valid. As you can see, we've enforced a must use, say you should not return this because it does not have the value as we've seen in the beginning. And the validation function will always look something like that. Up. Will always look something like that. You have the validation function, which will take as argument the input, possibly some conditions on what will make them valid or not, and it will return a result with either the validated input or or as an error the invalidity it has. Sometimes here, it's not on this function, but it's a good practice to type wrap this value to indicate it was validated, that you know it's a non-empty string or something like that. On strings it was a bit bothersome to do it, so we didn't do it. If you've seen my previous talk, you've seen that we've done that with IDs, model IDs, that we talked, I think, 6 months ago. You can then check the reason and attach your validation. As you can see, we had derived invalidity. The reason we did a derive for the invalidity is because writing where clause can be quite long. Here, you want to have your invalidity as generic as possible to accept anything that you can validate. For example, to validate the length of a string, we only need to be able to borrow the string. We don't need the actual string. And so, doing the trait, implementing the trait, I would have to write be generic on anything that implements borrow SOR, invalidity for the string invalidity. This is awesome. So it's actually really easy to generate a simple derive that just adds the where clause. You have, you can actually split for amp, which is first literally thought of that. You get directly the amp generics, type generics, and the where clause generated. Obviously, you'll try to provide specific invalidities for most of your fields: strings, floats, prices, variants, but you want to keep flexibility, and therefore, with the lowest flexibility you want, is just basically a string that says this doesn't fit. Small digression on invalidity X. So we had an issue when first coding the library, is that we wanted to ample from invalidity for boxed-in invalidity. Why? Because well, you want to, when you have different types of invalidities, you end up using dim invalidities, boxed-in invalidities, so that your function can return. For example, if your function needs to validate a string and an int, you'll return a dim invalidity. But if you try to implement that with, if you try literally to write this, you get a conflicting implementation because in Rust, every value, every type implements from itself, the identity function. And so we had to add a new direction through invalidity X, which is basically the same thing as invalidity, but allows us to amp from invalidity for the invalidity with the invalidity having invalidity X. Implementing invalidity X for boxed invalidity and not invalidity. Which means that in the following page, you will see invalidity X instead of invalidity. Basically, you just need to see invalidity. And last, we'll try to attach a source, the location of where this invalidity comes from. And we'll name this a field invalidity. Field invalidity is therefore the invalidity with the source of where we go. And this is what we'll return to our clients. This is what will be placed in our terminal for clarification or return as bad arguments on our APIs. If you're doing, if you're doing an API, for example, with Actix, you typically return with a bad request, and if you're writing gRPC, you will write invalid arguments with the display value of your field invalidity. And the display value of the field invalidity is really quite simple. You just display the source if you got one. If you don't, it's bad, it happens, with the invalidity behind. So the code will flow like this. First, you'll validate your data. As you can see, shipping data, as ref or missing. We want the reference, or we said it's a missing field, it was a requirement field. Then we'll attach the source. We'll say, oh, it's on-field data. And then we'll return if invalid. And the source will recursively be added by the callers, which means that this returns a dim field invalidity. This field invalidity will own only one source path, which would be the ID element, the field ID. We then have as here a result, which only has our one field, and we'll add the shipping address. And like this will allow us to simply display at the end shipping address dot ID is not valid. Developer experience. I'm sorry. So now that we see how we can display good errors, how we can propagate all the data we want to our end users, we now want to focus on the first challenge, which is provide a simple and explicit reading of validation. The objective one would be to transform the validation function as validated length lower than or equal from this to this. Because we thought it would fit better the logic flow. We think, I have my request, I have my field, and I want to impose this condition on my field, rather than start with the condition, then the field. And basically, it improves readability. For this, we'll use extension traits. Extension traits where we'll borrow strx, so typically for everything that has a length validation, where you'll be able to write, I will zoom, I can't zoom, amazing. Where we'll be able to implement my super long string. Yeah, I'm sorry, I thought we would see a bit better, but what's written is my super long string validated len LTE 15. We can say that we know that this has more than 15 characters, and display it. And we'll see receive my string should have at most 15 characters. Dot my super long string. Second objective will be to transform attaching a source manual way, which would be validated property of my field, and attach the field on the ability to something like this. So to attach a source, we need to think about what are different path elements that we can see. Basically, we kind of have three. We can have a field, which is the name field. We can have an index, which is basically an element in an array. And we can have an inconsistency between two fields. So this is bad practice to the API, but sometimes you don't have a choice. The value of a second field is that the list of accepted values of a second field is determined by a previous field within the payload. You want to be able to say to the user that it's the combination of those two fields that is invalid, even though individually each field is not invalid. And so we can attach a source to three types of different elements. Obviously, we want to be able to attach a source to invalidity. Say, okay, I want to add, I have my invalidity, I say it's in my field. Secondly, we want to be able to recursively do that. If we have shipping address .id, so we want to be able to attach a source to a field invalidity, which already has this information. And lastly, that's for the ergonomics, we want to be able to attach a source to a result containing a field invalidity, which enables us to avoid the malware. Last, one of the most used applications at Stockley on validation is with ITER. That's where we win the most time. You have iterators. It's really bothersome to add, to always don't forget to enumerate, so that you get the index of where it was, and to validate it. So I did a field on, you can extend the iterator trait to be able to have something like that. You'll get your iterator, which is currently an array of 1, 2, 0, 3, and you'll validate all. And what will validate all do? Validate all will enumerate your iterator, validate each element, and collect the resulting iterator in the specified type so that you get a collection of validated elements. And obviously, you can return an error, which would be if one of the elements is invalid, you can return this element, which allows you to do validated all my integer validated that it's strictly positive. Obviously, it doesn't work because we have the 0 here. On the theme my IDs, I can unwrap, I can add to string and compare it with my IDs 2 is less than or equal to 0, got 0. You can do a lot of funny things with iterator blends. First, up. You can have, first you can have validated find, which quite useful, allows us to select a specific item within an iterator. And one of the most used functions, which is validated all and non-empty by trying to, which is kind of the basic. Basically, most arrays you get, you kind of expect them to be non-empty. And the classical version you do is that you implement the trait try to with the error type of try to returning an invalidity, something on which you can attach a source anyway, and iterate trying to everything yourself, which allows to pretty things as if you have an empty input, if you have a validated of input field someone, some two, you can validate it all and try to unwrap and you get directly your output expected. To the short presentation. Do you have any questions? Yes?
Did you try using CRD directly to do this?
We have CRD, you can validate through CRD, but CRD, you can do it with CRD with, but it's harder to validate the length of the string. For example, one of our big use case is to validate that the length of strings is okay for us to fit them in our database, so that the string is less than 124 characters, which is doable with CRD. We have extension traits that we do CRD with validated less than LTE, but it's built on the top of our validation library.
And there is a validator crate. There is also a validator crate so that you have a lot of annotation for string validation, for the length and so on, for integer validation with the min, max, and all the stuff that. So I will check it.
So that fit very well with gRPC, all of that.
Do you validator crate?
No. Most, like, validator crate is based on URIs, right?
Yeah.
So the thing is, since our structures are all generated by from gRPC protos, we can do this.
Yeah, but you can in gRPC validation attribute to the gRPC generated fields, but it's kind of not.
It depends
not
what
to do that, but yes, gRPC validation is a nightmare. I have validation of gRPC too.
our classical use case is validation of gRPC because all our internal APIs are built with gRPC. And so you typically get something like that.
But yeah, in the long run, we would like to automatically generate the validation code associated to the gRPC structs from annotations in the proto file. This is not currently something that our connection allows us to do.
I tried to do that too. Really long.
So typically what we would have is we have our protocol file which describes our different APIs, which would then generate structures, something like that. And these are the kind of structures that we want to validate. We know that we can update our gRPC. We use gRPC RS and protocol RS to generate these structures. We know that there's better versions right now, but we still haven't done the migration. And then you would get something like that. which when you get big requests, something like that, you directly validate, okay, the order, as gRPC, all fields are optional, you can easily impose it as ref or missing on the field order, and then you validate on the, based on which emender provided the order. So that's kind of I think we can have order shipping data. You provide something where you see the client prices, you can validate with the VAT and something like that. Or inconsistency between client prices and consumer prices, which is typically the use case I was thinking about. Yes?
Just 2 questions. Maybe you mentioned, but forgot. Do you have a crate so we can use your...
We have not open source our crates.
Okay.
And the most reason for that is that we are in a monorepo where we have our crates, and so we would have to outsource our crates. We would have to outsource, to export our crates from our monorepo to specific crates, and most of our dependencies are written directly to paths, and so we will have to dynamically take this and change it to correct.
And second question, you said that you returned the values that was valid, it does not satisfy a property.
Yes.
Isn't it some cases where it could be a little bit dangerous, because then you return the values that is invalid, but these values, there are some values that you don't want to end up in logs, or not credentials, but maybe, you know, like AWS account IDs or stuff that are a bit sensitive. So sometimes you don't want values to propagate back. You want them somehow to disappear.
So you can still do that, because if you see the trait invalidity, it doesn't really impose anything. It just a marker that says, okay, this is invalidity, and I've followed this. So if you don't want to follow this and don't want to add the value, you can, while implementing invalidity on your structure, or implementing the display of your structure, not display the input value. So you could have a validated password with a password invalidity, and which would just not display the password in its display implementation.
Yeah. Okay.
But is it composable? I mean, if you have a validator for the password length, for example, and then you add another validator to hide the value, because for the password length you want to reuse your validator of string length, but this validator is generic, so it will provide the invalid value, and you want to hide it. So have you a way to compose it with a...
So we have not the use case, so we didn't do it, but probably what we could do here would be take this and apply a new function on the string validity, say hide password or drop value, which would then have a different display implementation that would not display the value.
Since the validate string length function does return a type error, you can just map the error to something else that will change.
And so all the validation strategy is in fact fail fast. I mean, you just stop the validation of the first error. You don't collect all the errors to have a big display of the
yes.
platform impure.
So there are few catchbacks on this strategy. First, as you can see here, the field is written to twice, as this field doesn't really have a value on Rust. We need to derive it to auto-validate it. We have to write twice order, which would be better. And secondly, yes, we first error and new drop.
Have you thought about just using macro to not write the name of the...
We thought about using macro, and the win in ergonomics was not enough for us to justify the added complexity. Basically, where with Stockly grows quite fast, and so we have a lot of new developers that arrive regularly. And one of the things we need to keep in mind in our code is the speed of ramp up of new developers at Stockly. And so if you add complexity in your code base for for low error limits, it's not worth it as a company. You have any other questions? No? Well, thanks a lot and let's drink.